So a lot of the standard template library actually makes zero sense until you see it in action. So just kind of recap here. The STL has algorithms. Those algorithms typically work on containers. Those containers hold data. Functions can also be templated. And you have iterators, which can iterate over the data in the containers. That's why it gets really, really confusing. So think algorithms, containers, and iterators all kind of go together, and functions, you can actually template those. So what are we really talking about here? Think of it this way. I clean my house, you clean your house or apartment, someone else cleans their dwelling, and so on and so on. Everybody cleans. If you can make a template so that everyone can clean regardless of who they are, your program's much more efficient. Let's go ahead and take a look here. So I have a function, I have a container, and I have some data types here. Let's say we want to make a function called add. And add is simply going to add two variables together. Okay, well, that's simple. I'm going to say add, and then we want to add an int and an int. So we can very easily take these guys and put them through this function, and it just works. Now, someone comes along and says, well, what about doubles? Well, doubles and ints aren't going to work well, so we have to, well, you guessed it, rewrite this specifically to take doubles. Okay, well, now I have two functions that do virtually the same thing. They're both going to add. And then somebody comes in and says, what if I want to add an int and a double? Crying out loud. Now I've got to go ahead and make yet another function. And this one is going to specify an int and a double. And then somebody else comes in and goes, well, what if I want to do a cat and a double, or a cat and a dog, or some infinite possibility? Really what we're getting at here is if you use simple logic and permutations, you see that you have an infinite number of functions because you can have an infinite number of data types. This gets insane. This is where the standard template library really comes in and says, okay, we're going to turn that function into a template function. So instead of this insanity, we can get rid of all this and say, all right, we want to add a type to a type. And as long as those types are the same, like int and int or double and double, this will just work. We can just throw it at it, and the compiler figures out at compile time what to actually make here. The only real problem here is if you come in with like cat and double, then you've got to actually break this out and do something like this, where you would say, int or HNT or whatever letter you wanted, anything that represents two different data types. So that really fundamentally is what we're talking about when we say a function in the standard template library, or taking a function and converting it to a templated function using the standard template library. Now let's talk about containers, algorithms, and iterators. Basically, and I'm just going to, for the sake of space here, move these around. We're talking about a container. A container simply contains data. But again, we have the same problem we had with the function, where if we define, let's say, a list, and this list is going to hold ints, it will only hold ints. And you guessed it, if we try to take that same container and put a double in here, or a cat, it's simply not going to work because the data type doesn't line up. And then the compiler is going to freak out and bad things will happen. So instead, you, of course, have a templated container. So you would have a list of a certain type, and you could say, I want to hold integers, and then you could put all the ints in there. Or, you know, of course, you could say doubles, and you could put all the doubles in there. This is extremely powerful and extremely cool. Now, when we flip back here, you're going to go, what about algorithms and iterators? So if you look at algorithms, they are, well, logic that operates on containers and sequences. So you can say, okay, I want to know some sort of value or I want to do some sort of operation on each one of these things. That would be the algorithms that are built into this. And you could say, well, I want to go through each one of these one at a time. So you would start at a position, and then you get this one, and then this one, and then this one, and you can move back and forth. It's actually extremely powerful compared to working with C++ without the standard template library. So in a nutshell, you can turn a function into a template function. You can have a container, which can have any infinite number of data types, and you can define that data type. And you can run algorithms over the information in the container, and you can iterate over each and every single item in the container. Wow, that is extremely powerful. Unfortunately, it's also extremely error prone, as we're going to demonstrate in the coming videos, especially when you add in the complexity that is Qt.